In this video, we're going to take a look at the 2006 AP Chemistry free response questions, specifically question number 8. So question 8 says, suppose that we have a stable element with atomic number 119 and symbol Q has been discovered. Write the ground state electron configuration for Q showing only the valence shell electrons. So when they say showing only the valence shell electrons, this means using the noble gas configuration. Now, what you'll notice is when you look at your AP periodic table, we have element 118, and that's a noble gas. So what we can do is say OG, and then we'd start a new row. This element has just been discovered, so your AP periodic table is not updated with this element. And so we would just say 8S1. Okay, B. Would Q be a metal or non-metal? And we need to explain in terms of electron configuration. So, of course, it's going to be a metal. And a good way to know that is it's on the metal side of the periodic table. But we need to be able to justify it using the electron configuration. So if you remember what the definition of a metal is a metal is the ability to lose electrons, okay? So I'm just going to put that here. The definition of a metal is the ability to lose electrons. So there's lots of ways you could justify this. I'm going to try to keep it short, and I'm just going to say elements with one valence electron tend to lose electrons most easily. Okay, part C says, on the basis of periodic trends, would Q have the largest atomic radius in its group, or would it have the smallest? And remember, a group is your vertical column on your periodic table. So would Q have the largest radius or the smallest, and explain in terms of electronic structure. So being in row 8 on the periodic table, Q would have the largest radius due to occupying the most energy levels of all elements in its group. Okay, D. What would be the most likely charge of the Q ion in its stable ionic compounds? So notice they don't ask us to justify here in letter D, so it would just be a +1 charge. All alkali metals have a +1 charge. You know, there's lots of ways you could justify it, but we're not asked to, so I wouldn't waste our time. And then in E, it says, write a balanced equation that would represent the reaction of Q with water. So this is going to be just a single replacement reaction. So we're going to take Q plus water, which is HOH. And the reason why we write HOH is because in a single replacement reaction, which is what we have here, Q and 1H will switch places. So we'll get QOH plus hydrogen gas. But we don't need to put states of matter here, but to get this balanced, I think, let's see, if I put a 2 here, a 2 here, and a 2 there, I think that now balances it. Okay, and then in part F it says, assume that Q reacts to form a carbonate compound. Write the formula of the compound formed between Q and the carbonate ion CO3 2-. So remember, Q is going to be +1, so we're going to need 2 Q's to neutralize a carbonate. So on F part 1, we're going to get Q2CO3. And then in part 2, it says predict whether or not the compound would be soluble in water, and to explain our reasoning. Lots of ways you could justify this. I think I'm going to write the easiest way to justify this. And then maybe I'll go into more detail. Let's just see. So I think it's going to be soluble in water. Solubility rules say all alkali metal ions are soluble in water. And a better answer and I would use this answer if they say justify in terms of Coulomb's law, I would say with a charge of +1 and a very large radius because of 8 occupied energy levels, the Coulombic attractions between Q +1 and any ion are not likely to be strong according to Coulomb's law. And then I would maybe even add that salts, which are ionic compounds, salts with low Coulombic attraction dissolve easier or dissolve more easily.